a worked example using transformers to step up the voltage. So we have a power plant producing 480 kilowatts of power of 240 volts. Part A, we're to estimate the power lost in the transmission lines, which have resistance 4 ohms, assuming no transformers are used. In part B, though, we're going to repeat the calculation in A using a transformer to step up the voltage from 240 volts to 380 kilovolts. So first, we have to find out the current in the wires. We do that using the formula P equals VI, which gives us I is P over V, which is 480 times 10 to the 3 divided by 2,400. .480 times 10 to the 3 divided by 2,400 gives me 200 amps. Then I use the power, assuming we lose power in the cables. P equals I squared R to be 200 squared times by 4. .200 squared times by 4 is 160 kilowatts power lost. So if I take 160 divided by 480, I get a third, or 0.33, or 33%. That means 33% of the power produced is lost. However, if we step up the voltage, we step down the current. So by using the formula, the ratio of the EMF in the primary coil divided by the ratio of the EMF in the secondary coil equals the current in the secondary coil divided by the current in the primary coil. Let's plug in our numbers. So the ratio, the EMF in the primary coil is going to be 2,400. The EMF in the secondary coil is this value, the voltage we step up, 3,800 times 10 to the 3. The current in our primary coil is going to be 200, but the current in our secondary coil is what we don't know. So to get the current in the secondary coil, we multiply up by 200. 200 times 2,400 divided by 380 times 10 to the 3. Now we have our current of 1.263 amps. Keep more sig figs than we need. Now we're going to use the same formula for power. Power lost this time is going to be 1.263 squared times by 4. Answer squared times by 4. We're only going to lose 6.38 watts. Which is 6.38 divided by 480 times 10 to the 3, 0.0000, 4 zeros, 13, or 0.0013%. So we lose much less power when we step up the voltage compared to when we have a low voltage.